So starting with this SISO, this is a register that is serial in, serial out. Here port equals clock and clear, that is in steady logic, and Q is out steady logic, steady underscore logic. Then is clock is closed, and then is end entity, then close it, and then again architecture. Architecture SISO, that is behavioral, BEHAVIOURL, behavioral of SISO is. You will write SISO is, and then begin, and then write process. Within process, we need to mention clock and then clear. Clock and clear, and then we need to insert serial in. Since input there will be one serial in, so SI clock and then clear. SI clock and clear, again then begin. Here we will write the logic as that if Q1 or Q0 is less than equals to SI, similar to that, we will write here that is Q of 0 is less than equals to SI. SI. SI is the input here. That's why it is not written within the inverted comma. And then Q of 1. Q of 1 is written as less than equals to Q of 1 is less than equals to Q of 0. Q of 0, but it is happening sequentially. Then Q of 2 is written as less than equals to Q of 1, and Q of 3, sorry, Q of 3, it is written as less than equals to Q of 2, and then close the colon, and then again end process, end process, and architecture, and architecture. And architecture, then close. Let us see is it working or not. It is showing it as 8 errors. Okay, and we have not used clock. Okay, fine. Yes, there may be some error. If CLR is equal to 0, then Q uh, Q is less than equals to, within colon we have to write less than equals to 0 0 0, and then colon close, and again if else if clock equal to 1, clock equal to 1, and clock event, and clock event, then Q equals to this much. you have to and if, then is end process, then is end architecture, and then save it, and then compile it. It is again showing error. It is in out. It is showing that queue is not acting as array. So in out std logic underscore vector, and vector size is 3 down to 0. So it is 3 down to 0. Save it. Register. Yes, it is successfully compiled. And let us SISO. File name is SISO. So on simulating, you have to select this file SISO, serial in and serial out. Yes, it is SISO is visible here. Then on instant window, you have to add all the items to the wave. Add to wave all items in the region. These are the inputs as well as output. You should know which are input and which are output, and which is acting as input as well as output. So here serial in, let us take it as a clock pulse, so that we can see the variation whether it is obtained, or let us take it as initially as a binary number. So it is 1 here. It is 1 clock. We are forcing clock to 100 PS. It is okay. Then is clear. Clear, we are putting it to 0, and then Q, we are putting it force to 40, and then there is no force since it is not acting as output. It is acting as input as well as output. So initially you have to initialize it to 0, and then no force. That is actually it is not acting as output now. Now simulating. See, output is always 0, though input is 1, but no flip-flop is accepting the input. That's why here you can see, basically these are the 4 register that are connected. Maybe register maybe of JK, or maybe of T type, or maybe of D type. So suppose D, it is acting as a flip flop number 1, that is has 1, has 0, has 1, it is of has 2, it is of has 3. Has 3. This output is acting as input here. This output is acting as input here. This output is acting as input here. These all are of D type, and clock is applied here. This clock is applied. So just we are programming this architecture through VHDL code. So here initially these all clear are active. This all clear are active, and D is 1. That is leftmost input is 1, and these clear are active. It is actually 0. That's why all the output is 0. You can see at the simulation portion, even if even if input is 1, output is 0. Now if clear is at 1, then try to see what is happening here. If clear is 1 and simulating it, see, you can see it is now it is acting. See, for the first portion it is 1. Again data is 1. That's why both the inputs are 1. Again data is 1. So all the three are 1. And again data is 1. So all the four are 1. Now if again I am simulating, then all the status will remain same. Actually, we can see that 4 bit, that is 1111. These all 4 has been stored in, that is see, initially it was 1, all are 0. That's why output is 0001. Then the next clock, this one has reached here, and again data is 1. That's why output is 0011. Now this one has again reached here, so output is 0111. Again this output has reached here, so output is 1111. 4 times 1 it is showing. So here we can see that output is migrating from one position to other. आप इसमें जो है ये क्लास now suppose we are taking this SI, we are keeping this SI as